let's look at this first function. F of x equals 7x cubed minus 5x squared plus x. Is the degree of that even or odd? What is the degree? What degree is that polynomial? Okay, let me break it down for you. What's the highest exponent?
3.
3. So degree 3, which right, Demaya, is cubic. Is that even or odd? Odd. Now, let's say that you were having trouble figuring out whether it was even or odd by just looking at the function. Let's graph it. Okay, when you go into your calculator, you'll hit y equals. Okay, now look, there will be stuff in there from the last period, so you need to hit clear to get it out. And now we're going to type in this function. So you would type 7. Okay, to get the x, you type this button up here, see where I'm hovering? And then to cube it, we would need to hit caret, which is right below the clear button, and then 3.
We didn't graph right.
Not yet, we haven't typed in the whole thing. 7, and then x is that button right here. And then you have to cube it, so you would put caret 3. Now, do you see how it's blinking right there up near the 3? That means we need to arrow over to get it back down to normal size, because it was at the exponent. We don't want our next thing we type in to be an exponent. Okay, so now we need to type in minus 5x squared. Now, we have two different options to square it. You can do caret 2, like we did the cube, or there's a shortcut button. See over here, this button that says x squared? That's just a shortcut where you don't have to use caret first. And then plus x. Now hit graph. Okay, what do you notice about the end behavior of that graph? On both sides? So it's going opposite directions, right? One side's going down, one side's going up. Well, don't you know when it's odd that it goes opposite directions? We learned that last week. Okay, now, we already established that it's cubic, and that's because it's degree 3. 3 is the highest exponent. What is its second name? Cubic what? Trinomial. Thank you, Demaya. And it's trinomial because it has 1, 2, 3 terms. So, what is the first term, the leading term? 7x cubed. Now, of that term, we know that 3 is the exponent. What is the coefficient? 7 is the coefficient of the term. Is that positive or negative? Positive. That's a positive 7. So the sign of the leading coefficient is positive. Okay, now let's look at this one. G of x equals negative x to the 4th plus 2x squared minus 6x minus 5. Is that even or odd? Even. It's degree 4. What do we call degree 4 polynomials? Quartic. Good. Quartic. What is the leading term?
1.
Negative x to the 4th. They want this is the whole term. Okay, how many terms are in that one? 4. Okay, what is the coefficient of the third term? Negative 6. What is the constant? Negative 5. Remember, a coefficient is the number with the variable. If it doesn't have a variable, it's called a constant. Okay, what is the sign of the leading coefficient? Negative. Because isn't that a negative 1 beside the x to the 4th?
Yeah.
Okay. Now, like we've been talking about, we can have even graphs or we can have odd graphs. Yes? You look at the degree. 4 is an even number, the highest exponent. No. I just asked an extra question. I said, what's the coefficient of the third term? I was just practicing. Okay, now let's look at this. You have even graphs and you have odd graphs. These two graphs, the first two, are both what? They're both even. Now they look different. This one's opening up, this one's opening down. But to be even, you just have to have the ends going in the same direction. Aren't these both going up? And these are both going down? So since their end behavior is the same direction, they're even. Now, is this a positive even or a negative even? Positive, because they're both going up. So therefore, this one would be negative even. Now over here, both of these would be considered odd because they're both going in opposite directions on their ends. Is this positive odd or negative odd? Positive. Look, from left to right, aren't you going up? Remember, we read left to right, so same thing with graphs. From left to right, you're going up. So this one from left to right is going down, so it's negative and odd. Okay, now let's look at this first question. Y equals x cubed, and that probably got hole punched on your paper, so you might want to write it above it, x cubed, plus 2x squared minus 11x minus 12 equals, okay, so we have x cubed plus 2x squared minus 11x minus 12 equals x plus 4 times x plus 1 times x minus 3. Now, yeah, you're probably thinking, what in the heck, what is all that? Well, let me go back to 9th grade for you for a second. Okay. X squared plus 7x plus 10. I know in 9th grade, and maybe even before that, you learned how to factor a quadratic trinomial. You didn't know it was named a quadratic trinomial, but you learned how to factor it. Remember how we put it into two binomials, and each one of them had an x to make that x squared? And you were looking for numbers that added up to 7 and multiplied to 10?
That was last year.
What numbers will do that?
Wait, you're supposed to add.
Add to 7, 5 and 2. 5 plus 2 is 7. 5 times 2 is 10. But guys, aren't those the same thing? One is just factored form and one is non-factored form? Because think about it. Watch this. If I FOIL this, x times x is x squared, x times 2 is 2x, 5 times x is positive 5x, and 5 times 2 is 10. Then I would just combine those like terms in the middle, and I would get back what I started with. So like I said, they're the same thing. This is just factored form of this trinomial, but they're the same thing. Okay, now it is the same thing for this. This is just the factored form of this cubic polynomial. Like if I took these two and FOILed them, got a trinomial, and distributed them to this binomial, it would give me back that. Okay, if you don't believe me, we'll graph it and I'll prove it to you. Okay, but before we do that, we're going to talk about how to find the zeros. Okay, so we're going to first practice by finding the zeros of this one that I made up. So let me erase all this. Yeah, I just did. Okay. Okay, remember, we're trying to find the zeros. Okay, we're trying to find the zeros. On track. Okay, so remember, we're trying to find zeros. Well, to find zeros, you're going to take each of those factors and set them to 0. Okay, because we're trying to find zeros. So, to get x by itself, what do? Subtract 5. And that gives us a negative 5. Because 0 minus 5 is negative 5. To solve for this x, what do? Okay, and we get x equals negative 2. So the zeros of this trinomial are negative 5 and negative 2. Well, let me show you what zeros also are. I'm going to graph it. You don't have to graph it, just watch. X squared plus 7x plus 10. Where does that graph cross the x-axis? Negative 5 and negative 2. So what is zeros another name for? X-intercepts, right? Because you see that the zeros were negative 5 and negative 2. Well, that's where it crossed. So zeros is just another name for x-intercepts. Now let me show you one other thing. Remember how when we factored this, it was x plus 5 times x plus 2? I'm going to graph that now. X plus 5 times x plus 2. And then it just cover it up. It's the same graph. So now don't you believe me that those are the same thing? This is just non-factored form. This is factored form. Same thing with this one. This is not factored. This one is. So, like you just saw, to find the zeros of a function, don't you just look at the factors and give me the opposite? Like instead of x plus 5, you'll get a negative 5. Instead of x plus 2, when you set it equal to 0, you'll get a negative 2. Okay, so how many zeros are in this function? 3. And the reason that is because it's cubic. It's degree 3. What are those 3 zeros? Right? Now, what did we just talk about? Zeros are just the same thing as x-intercepts. So can we go and plot those as x-intercepts? Okay, let's talk about another reason they are called zeros. When you have a point on the x-axis, what's the y value of it? 0. Okay, now, is this degree even or odd? Odd. It's cubic. Okay, so what does that let you know about the graph before you even see it? Opposite directions, right? That means one side's going to go down, one side's going to go up. But you have to figure out which. What's the sign of the leading coefficient? Well, what's the leading term? X cubed. So the coefficient is 1. Is that a positive 1 or a negative 1? Positive. So doesn't that mean if they're going opposite ways, but it's positive, it'll go down on the left and up on the right? Okay, so now to actually get a sketch, we're going to graph it. So go to your calculator, and this is what I want to do. From the row that Ada is on over to the wall, when you graph it, you're going to type in this, x cubed plus 2x squared minus 11x minus 12. Everybody else is going to type in the 3 factors when they graph it. Over there. You're typing in this part. Diamond.
Well, there goes your brand new calculator.
Wow, first one of the day, Jake. Does your graph look like that?
Sure does.
Okay, so now we can do a sketch of it. Okay, but the only thing we can't see is where it crosses the y-axis. If you want to know the y-intercept, see this button up here by graph that says trace? You just hit it once, it pops up your y-intercept, 0, negative 12. Now, as you can see, that our graph only goes down to negative 5, which this would be negative 6. So you would just plot your y-intercept down here. It looks like this. Okay, bring it up so I can check it. Okay, so now look, you just need to do a rough sketch of it. Okay, now that we have a rough sketch of the graph, we can do the end behavior. Remind me again what this x arrow infinity means. Okay, well, when you're thinking about the x-axis, you're thinking in terms of what directions? Left or right? Well, if they tell you x approaches positive infinity, they're telling you to go which way? Right. So if I'm on this function and I travel to the right side of it, what am I doing on the y-axis? Okay, look, I'm trying to get my pen on so I can show you. It'll come on. Over there, but it's not responding. There it is. Okay, so if I'm on this function and I start going to the right side of it, I eventually go where forever? Up forever. So as you go to the right, your y values go to positive infinity because they go up forever. But if I'm on the function and I go to the left side forever, I end up going where on the y? Down forever. Well, doesn't it make complete sense? You end up with opposites since our function is odd and they go opposite directions. Okay, now let's try this one. X to the 4th minus 5x squared plus 4. This time we have 4 factors, and why is that? It's degree 4. Look, it's degree 4. See how the 4 is the highest exponent? What do we call degree 4? Quartic. Okay, what are the zeros of this function? Right? And what are zeros also known as? X-intercepts. So we can go ahead and plot those. Okay, now, is the degree even or odd? Even, because it's degree 4. So, since it's even, what do we know about our graph before we even graphed it?
They're both going to go in.
They're going to go in the same direction. Now, to know if they both go up or both go down, you have to look at the leading coefficient. What is the leading coefficient? Positive 1 out in front of that x to the 4, so positive. Okay, so now let's graph it and see what it looks like. Okay, so we have x to the 4th. And remember, you can graph either one. This is shorter, so I'm going to graph that this time. So x to the 4th minus 5x squared plus 4. And your graph should look kind of like a W. Now, how do I find the y-intercept? Hit trace. And so the y-intercept is where? 4. So I can go ahead and plot it. 1, 2, 3, 4. And then, if you just look at your graph, where does it come down and change directions at each time? About -2. So you just do a rough sketch. Okay, now that we have our sketch of the graph, let's talk about end behavior. As x goes to infinity, what does y do? It goes up. Because think about it, if you go to the right side of that graph, don't you end up going up forever? What about if you go to the left side? Up. And doesn't it make sense that they're the same since it's even? And that means it goes the same direction? Okay, now turn to the next page. No, we got more. Okay, on this page, this is a typo. Get rid of that 3 and replace it with a 9.
What?
Just replace that 3 with a 9. Okay, so this time we have how many zeros? 2. Why is that? Right, it's quadratic, degree 2. What are those zeros? Okay, zeros are also x-intercepts, so we can go and plot them. Okay, is it even or odd? Even. What does that tell us about the end behavior? They're both going the same. So far, we only know the same. You don't know that they're both going up until you get to the leading coefficient. What is the leading coefficient? Positive 1. But really all we care about is positive. So yes, they're going to both go up. Now, to sketch it, we need to graph and see what it looks like. So y equals x squared minus 9. And what do we have? What do we call that? Parabola. Remember, anytime you have a quadratic equation, it's a parabola. Where does that parabola cross the y-intercept? -9. So you hit trace, and it'll tell you -9. Now, -9 is obviously off this graph, so I'm just going to estimate. Okay, and now that we have a sketch, we can look at the end behavior. Okay, as x approaches infinity, what does y approach? Positive infinity. As x approaches negative infinity, what does y approach? Positive infinity. No, we're just doing rough sketches. This was if we wanted to make up x values, plug them in, get the y values, and plot points. But a lot of the points are way off the graph, so that's why we're just doing a sketch. Okay, over here in this last one, well, for today, what does x minus 3 squared literally mean? It means there's 2 of them. So instead of writing it like that, couldn't it have just been written like this? So how many zeros are there? 2. But they repeat. Okay, that's called multiplicity of 2, and we'll get more into that tomorrow. Okay, what's the degree? Even, so that tells you what about the graph? They're going to go the same direction. What is the leading coefficient? positive 1, so positive, because all they want is the sign. All right, so we know that both of them are going to go how on the ends? Up. Okay, because if it's the same, they go the same way. Since it's positive, they both go up. All right, so let's do a sketch. I'm going to put it in my calculator. Y equals x squared minus 6x plus 9. Okay, how do I get the y-intercept? Trace, and it's at 9, okay, which is up here on the graph. And then it's 0 is at 3, its x-intercept's at 3. Now, let's talk about something. See how this one comes down and hits the x-intercept but doesn't pass through it? This is called a bounce. See how over here they went right through the x-axis, but over here it's like it comes down, bounces off of it, and goes back up? That bounce occurred because of this multiplicity, because there were multiples. There were 2 of those. So, we'll talk more about that tomorrow, but to finish up, let's do the end behavior. No matter which way if you go on this graph, to the right or to the left, what do you end up doing on the y? Going up. And remember, they should be the same because we're dealing with an even graph.
Is it always been like that?
Yes. But like if it were same and the leading coefficient were negative, both of these would have been negative infinity. Okay, you can switch out.